Every galaxy in the observable universe is moving away from every other galaxy right now as you watch this, not because of some explosion pushing them apart, not because they're fleeing a center point. Space itself is stretching. And here's the question that trips up even people who have thought about this for years. What is it stretching into? By the end of this video, you'll understand exactly why that question is harder and stranger than it sounds. In the 1920s, astronomer Edwin Hubble was studying distant galaxies from an observatory in California, measuring the light coming from them. He noticed something consistent. The light from nearly every galaxy was shifted toward the red end of the spectrum. This is called redshift. The underlying principle is the same one behind the Doppler effect you already know from sound. An ambulance siren sounds higher pitched as it approaches and lower pitched as it recedes, because the sound waves compress and stretch depending on relative motion. Light behaves the same way. When a galaxy moves away from us, its light waves stretch, shifting toward red. Hubble found this pattern almost everywhere he looked. Galaxy after galaxy redshifted. But the more important finding was this: the farther away a galaxy is, the faster it appears to be receding. Distance and velocity scaled together linearly. That relationship is now called Hubble's law, and it remains one of the foundational pieces of evidence for cosmic expansion. If everything appears to be moving away from us specifically, it's reasonable to wonder whether we are sitting at the centre of the universe. We are not, and the reasoning behind that is worth walking through, because it's the same logic used later to describe expansion more rigorously. Picture dots drawn on the surface of a balloon. As the balloon inflates, every dot moves away from every other dot, and critically, an observer sitting on any dot would see the exact same thing, all other dots receding at a rate proportional to their distance. There's no dot that's special, no dot at the centre. The expansion is a property of the surface itself, not motion relative to some fixed point on it. That's the same situation we are in. Every galaxy observes every other galaxy receding, because space itself is expanding uniformly. Earth isn't a privileged location. We'd see this exact pattern from anywhere in the universe. Redshift is compelling, but scientists had a second independent line of evidence to check it against. In 1965, two Bell Labs engineers, Arno Penzias and Robert Wilson, were calibrating a radio antenna and kept detecting a faint, uniform background hiss. It appeared no matter where they pointed the instrument. After ruling out equipment issues, including famously pigeon droppings on the antenna, they realised they'd stumbled onto something enormous. Residual radiation left over from the early universe, now known as the cosmic microwave background, or CMB. Roughly 13.8 billion years ago, the universe was extremely hot and dense. As it expanded, it cooled, the same way a gas cools as it expands into a larger volume. Eventually it cooled enough for photons to travel freely for the first time, roughly 380,000 years after the Big Bang. That light has been stretching along with space ever since, and today it shows up as a faint microwave signal, almost perfectly uniform in every direction. The CMB is direct observational evidence of an early hot, dense state, and its properties match the predictions of an expanding universe with remarkable precision. Now to the question at the centre of this video. The most accurate current answer is, it's probably not expanding into anything at all. That deserves some unpacking, because it's a genuinely counterintuitive idea. Go back to the balloon. Its surface expands into the three-dimensional air around it. But a hypothetical two-dimensional being living on that surface would have no access to that third dimension. Its entire reality is the surface. There is no outside it could point to, because its whole existence is confined to that 2D space. Here's the key difference with our actual universe. We don't have good evidence for an equivalent of the air around the balloon. As far as cosmology can currently tell, our 3 spatial dimensions plus time constitute the entirety of physical reality. Space isn't a set of objects sitting inside some larger container. Space itself is the fabric being described, and that fabric is what's stretching. So the question, what is the universe expanding into, implicitly assumes there's a larger space our universe is embedded in. But nothing in general relativity, which is the theory that actually describes this expansion, requires that assumption, and no observation has ever indicated one. A useful comparison, asking what's north of the North Pole. North is a perfectly meaningful direction almost everywhere on Earth, but standing exactly at the pole, the concept itself stops applying, not because you've run out of physical space, but because you've run out of the concept that gave the question meaning in the first place. Expanding into may be a question built on an assumption that doesn't hold. What the evidence actually shows is that the distances between galaxies are increasing, everywhere, uniformly, which is a statement about the geometry of space itself, not about an object moving through some pre-existing void. To be fair to the open questions here, some theoretical frameworks, including certain versions of eternal inflation or multiverse models in string theory, do propose structures beyond our observable universe. These remain speculative. They aren't ruled out, but they also don't currently have direct observational support, and physicists are generally upfront that this sits at the edge of what's testable with current methods. To summarise the case, redshift shows that galaxies are receding, with velocity increasing proportionally to distance, Hubble's law. This pattern is not evidence that we are at the centre. It's exactly what uniform expansion looks like from any vantage point. The cosmic microwave background is direct evidence of the universe's hot, dense early state, independently confirming the expansion. What is it expanding into is likely a category error. The evidence points to space itself as the thing that's stretching, with no requirement for a larger container. Some speculative theories propose something beyond, but these remain unconfirmed. Cosmic expansion isn't just a curiosity, it's the basis for calculating the universe's age at roughly 13.8 billion years, and it's central to how we understand the universe's origin and structure.